Okay, we continue with the previous topic about frequency response analysis. So in the previous lectures, we discussed upon what is the transfer function, open loop and closed loop transfer function. Now, what is the advantage of frequency response approach? We can use the data obtained from the measurements and the physical form without deriving its mathematical model. Okay, so without deriving mathematical model, by observing the data, by measuring the data of the system, physical systems, we can analyze the response of system for various inputs. So frequency response tests are in general simple and can be made accurately by use of readily available sinusoidal signal generators and precise measurement equipment. So these tests can be conducted by giving input sinusoidal input signals and measuring the response using the measuring equipments. The third one, what is the advantage? Third advantage, the transfer function of complicated components can be determined experimentally by frequency response analysis. So, for complex systems, frequency response is very easy to analyze the stability of the system. So, for complicated system, this is very much suitable. Then, fourth one is a system may be designed so that the effects of undesirable noise are negligible. So, complex systems can be designed to reduce the noise, and that such analysis and design can be extended to certain nonlinear control systems. So, for nonlinear control systems, frequency response approaches is much beneficial. Right. Next, we discuss upon frequency domain specifications. There are certain definitions on about frequency domain specifications. If by measuring these parameters, these list of parameters, we can study the frequency domain analysis. Right. The performance characteristics of a system in frequency domain are measured in terms of frequency domain specifications. Frequency domain specifications are okay. Here I have listed six parameters. First one is a resonant peak. Second one is this MR represented by M suffix R. Then resonant frequency omega R. Third one bandwidth, that is bandwidth omega H. Fourth one is cutoff rate. Fifth one gain margin kg. And sixth one is phase margin omega. Right. So we discuss upon the frequency domain specifications one by one. So to first is to start with, what is resonant peak? So the maximum, what is resonant peak? So peak is the maximum value. You all know what is resonance. When the system gets disturbed, the parameters just starts uh, rapidly. It changes to high value. That thing we call it as a resonance, right? If during lightning time and thunder time, the voltage and the current of the system gets drastically increased. That is resonance, transient resonance. So then what is resonant peak? The maximum value of magnitude of closed loop transfer function is called resonant peak. So maximum value of magnitude of closed loop transfer function. So resonant peak we measured for closed loop transfer function. Our large resonant peak corresponds to a large overshoot in transient response. Right. So large, this a large. If the system gets overshooted heavily after a transient, that thing we call it as resonant peak. So this is for second order systems. I have given a formula here. Resonant peak MR equals 1 divided by 2 zeta square root of 1 minus zeta squared. Zeta is our damping ratio. Damping ratio to stop the oscillations, to stop the um, um, translations, disturbances, oscillations, we call it as a damping. right? So next is resonant peak, then resonant frequency. Then what is resonant frequency? The frequency at which the resonant peak occurs is called resonant frequency. Okay, but so at resonance frequency, the frequency at which the resonance occurs we call it as resonant frequency. This is related to frequency of oscillations in step response. Okay, when the input applied is step input, the frequency at resonance time we call it as resonance frequency. So indicative of speed of transient response of a second order system. So for second order system, what is the formula of resonant frequency? UR omega r by omega n equals square root of 1 minus 2 zeta squared. Zeta is my damping ratio. So the resonant frequency omega r equals omega n into square root of 1 minus 2 zeta squared. Right. So we'll continue the remaining things in the next lecture. Thanks for watching. Thank you.